Global freight operates on predictability. When macroeconomic policies shift rapidly, that predictability shatters, introducing severe friction into every link of the supply chain. We are anchoring our origin point in Turkey, a manufacturing hub currently navigating a rapidly shifting transatlantic trade environment. The operations moving out of this region represent millions of TEUs and billions of dollars in landed goods. The sheer physical density of these export volumes makes them difficult to maneuver when regulations suddenly change. Under traditional modeling, architects built direct paths from Turkey to the US for the lowest transit cost. But 2026 mandates for deficit reduction and secondary sanctions block this direct route. Transit costs spike as regulatory barriers materialize, erasing planned profit margins. Standard cost optimization formulas rely on historical averages and lack the variables to process overnight tariff hikes or sudden compliance blockades. In this environment, a direct point-to-point route functions as a single point of failure, exposing every shipment to immediate seizure or margin collapse. This friction stems from a specific policy mandate, the U.S. administration's public commitment to project a national trade surplus by the end of 2026. Current leadership has established a clear precedent for using broad tariff applications to achieve these macroeconomic objectives. Optionality in network design provides the only mechanism to mathematically absorb these policy shocks without liquidating profit margins. A control tower framework requires an architecture built to process regulatory threats in real time and reroute capital before margins are compromised. Securing a supply chain against these shifts requires physical node diversification rather than reliance on route negotiation. This diagram illustrates the standard landed cost calculation: manufacturing plus freight, plus duties and tariffs, plus insurance. One specific variable is currently responsible for the majority of budget overruns across the Atlantic corridor. As the U.S. administration moves towards its trade surplus targets, the resulting tariff yields compress Turkish import margins towards zero. Because these deficit targets have fixed deadlines, the probability of sudden tariff applications, or non-tariff barriers, remains high throughout the fiscal year. Using a fixed annual percentage to calculate duty costs ignores the actual financial risk of mid-quarter policy changes. We model the tariff variable as a dynamic probability distribution curve. This curve plots the expected frequency of geopolitical shocks against the potential severity of tariff spikes based on current policy signals. Injecting this probability distribution into the landed cost formula shifts the baseline requirement for operating capital upward to account for potential volatility. Logistics models that ignore tariff volatility as a dynamic probability effectively hide the true financial exposure of the enterprise. Tariffs are only the first constraint. Turkey shares borders and trade links with regions operating under heavy international sanctions. The nation occupies a transitional position where legitimate trade and restricted markets often intersect. This diagram reveals that a single origin point is actually a web of sub-suppliers providing raw materials and components. When these lower tiers source materials from sanctioned nations, the risk of structural contamination in the final product increases. Standard protocols typically verify only the direct manufacturer, leaving the origin of Tier 3 components unexamined. If a Tier 3 vendor sources a restricted component, that violation travels up the chain and contaminates the entire container load. Prevention requires deep tier origin due diligence, where every subcomponent is forensically traced before assembly. Contaminated cargo is seized at the border, triggering secondary tariffs or federal embargoes that stop all inbound flow. A compliance failure at the Tier 3 level triggers federal enforcement actions that freeze every active shipment in the network, regardless of its specific origin. This diagram shows the macro reality. The direct path from Turkey to the U.S. is saturated with physical and regulatory friction. Single-stage origin-to-destination pipelines offer no defense against these systemic shocks. We engineer agility into the system by establishing physical node diversification through nearshoring. For North American imports, Canada serves as a strategic buffer to absorb this volatility. This diagram demonstrates the integration. Adding a Canadian hub allows us to divert volume away from volatile U.S. entry points. Routing through Canada provides a layer of regulatory insulation between the origin and the U.S. market. This footprint allows you to stage inventory in bonded facilities located outside of the immediate U.S. tariff zone. Staging allows an importer to restructure bulk shipments or hold goods until a punitive tariff spike subsides. controlling the exact timing of U.S. entry. Once verified, the flow continues unimpeded into the U.S. distribution network, bypassing the friction points of the direct lane. In a high-tariff environment, the financial savings of bypassing penalty rates outweigh the traditional logistics costs of adding distance and time. This diagram shows the complete architecture, where the entire supply chain is managed as an integrated system by a central control tower. The 2026 trade corridor is unpredictable. Policy will continue to shift to meet national trade targets. When simultaneous shocks hit, a sanction alert at the origin and a tariff spike at the border, the system adjusts instantly. The control tower automatically throttles volume on the restricted direct lanes and expands the flow through the nearshore Canadian buffer. Total system volume reaching U.S. distribution centers remains stable despite the disruption at the origin point. Maintaining actual trade continuity in this corridor requires moving away from the outdated concept of a rigid, static shipping lane. Protecting margins requires calculating probability, tracing of sub-suppliers, and building physical off-ramps into the logistics network. Engineering agility into the supply chain architecture ensures that volatility at the border results in a route adjustment rather than a total operational shutdown.